In this section, I will be discussing about the MAC. Following the previous section on the MAC emitting MAC addresses from the Barrett Corps in Mexico. From the triple backs or covax chip date corps. Between 2020 and 2021, here is the explanation concerning the medical observation of the MAC emitting address, self-assembling electronic circuitry microchip construction. I'll be using the illustrative pattern of the Intel. First is the programmable neuron core with on-chip learning and stochastic time step control. The second legal exam is the Intel pattern, reconfigurable neurosynaptic cores for spiking neural network, configurable neurosynaptic cores for firing neural network, and the third is the Intel pattern for computing near memory convolution accelerator. And the next one is using the IBM pattern, the neural network, and the neural core circuit to be of assistance in explaining how is it that the date corps in the covax chip in corps in the Mexico were able to produce MAC emitting address from self-assembly electronic circuitry microchip construction. The questions that we will be answering in this section is under 4.2, under International Criminal Law, bioweapon covax MAC emitting address generator of self-assembling electronic circuitry. Question 1 is, how does the Intel programmable neuron core with on-chip learning and stochastic time step control work? How does the reconfigurable neurosynaptic cores for spiking neural network work? And how does compute near memory convolution accelerator work? The MAC or medical observation of the MAC emitting address self-assembling electronic circuitry microchip construction, or the MAC address generator producing random numbers. Under 4.2.1, the Intel pattern, programmable neuron core with on-chip learning and stochastic time step control. In the title, pattern by Intel as an illustrative blueprint to explain this phenomenon of MAC emitting address, programmable neuron core with on-chip learning and stochastic time step control is explained first. A time step controller under GDPR law on integrated circuited could be, for example, a covax chip IC to activate a time step update signal to perform a time multiplex selection of a group of neuromorphic states. The integrated circuit includes first the circuitry responsive to detecting the time step update signal for a selected group of neuromorphic system states. Third, to generate outgoing data signal. For example, an identifier MAC identifies a group and memory address that corresponds to the memory block associated with integrated chip circuit in brain in the date corps in response to determining first membrane potential of a select group of neuromorphic states that exceeds the threshold value. The logic circuitry compares a sequencing portion of the updated value with a programmable scan value and activate the time step update signal responsive to sequencing portion, matching the programmable scan value, the time step update signal select, a group of neuromorphic states with address provided by address portion of the updated value with address that corresponds to location within a register set for storing the group of neuromorphic states. To recap, a neuron in a neuromorphic computing system is a computational sub-block of the core computation block that performs spike time-dependent plasticity, or STDP for short, based learning, a type of Hebbian learning induced by type temporal correlations between spikes of pre- and post-synaptic neurons. First, the presynaptic neuron sends output spike to fan-out connected neurons that are weighted. Second, the postsynaptic neuron receives the spike and associated weights from fan-in connected neurons. Third, if a presynaptic neuron spikes earlier than postsynaptic neuron, the likelihood that presynapse-induced spiking of postsynapse is high, and includes associated memory block called synapse or synaptic memory. Intel defines parameters as various factors: membrane potential, counters, control bits, spike threshold, spike rate, etc., that impact arithmetic computations within a neuron block. Next, examining the MAC emitting address self-assembling electronic circuitry microchip construction in COVAX chip date corps. Medical observation: the MAC address generator producing random numbers. Using the illustrative legal exhibit of Intel pattern reconfigurable neural synapse cores for spiking an neural network. This is an exemplary criminal exhibit, figure 4 synapse address generator, small or large array neuron processor. Clearly, it demarcates the difference between figure 4, which is synapse add generator neuron processor, which is the definition of the legal term processor redefined, with an illustrative blueprint, and also further elaborated in conjunction with the loophole in the legislation. Figure 5 is synapse weight. And the final illustrative diagrammatic blueprint is the membrane potentials functional computation logic diagram. As seen here clearly in this Intel pattern with figures headings highlighting the criminal intrusion types, reconfigurable neural synapse cores for spiking neural network. The processor under the Data Protection Law or GDPR comprises of a first neural synapse core consisting of first circuitry configuration of first neuron synapse core as neuron core responsive to first value and second value specified by configuration parameter, and configure the first neuron synapse core as synapse core responsive to second value specified by configuration parameter. This is an ancient replica that is a copied pattern. Here you can see that there is a router connected to the core, and you can also see this field array in the, for example, the legal exhibit and medical evidence by Dr. Nixon. And within each chip, you can see that there is a north, south, east, west port for example, radio frequency. And you can see over here that in this one chip, there is a neural synapse core block, a first neural synapse core with resource configuration parameter and a second neural synapse core connected to the router. The Intel Corp definition of neural network, or NN, refers to a cluster of neurons connected by synapse to other neurons via links that are excitatory or inhibitory in effect activation states of connected neurons. And second, it can be trained or adapted to perform data processing tasks, for example, data classification. For example, in figure 1 shows a processor 100 diagram, microprocessor, embedded processor, digital signal processor, network processor, application processor, etc., comprising of network on-chip or NOC system that implements the neural network. Figure 1 shows the COVAX 1 microprocessor 100 under data protection law, embedded processor, digital signal processor, network processor, handheld processor, application processor, coprocessor SoC, single router that can be circuit switched or packet switched. Network includes buffering logic enabling providing intra-die communications between components, for example, cores, storage, or other logic blocks, with packets including a control portion. The control portion, which is also the correct legal definition of the word controller, include destination address of packet that corresponds to one of the network elements The legal definition of the control portion of packets transferred between routers based on packet clock, for example, a 4 GHz clock. For example, event 201 NY, which is timed with for example, a review of the Wuhan Ports drill and Wuhan military games by the WLC and the potential strategic breaches committed total number of times steps. B, the data portion of the GDPR or legal definition omitted of contains specific data to be communicated to the processor. Again, a legal definition defined. Processor 100 of NOC connected to its logic cores 108 with a unique clock or voltage or other device that execute code, comprising of a network on chip or NOC for short, system that comprises of a neurosynaptic core block. For example, more than one neurosynaptic cores to implement one or more neurons or more synapses on the neural network NN. Second, it comprises of one or more computational logic blocks that are time multiplexed across neurons and or synapses of neurosynapse core. Criminal mode of operation, intent criminal act, legal definition of processor or data protection law, binary space law, international criminal law. Referring to Figure 1, the processor 100 includes a plurality of network elements 102, and each network element 102 is arranged in a grid network. Includes router 104, packet switch network, circuit switch network, is communicatively coupled to multiple cores, 108 that contains symmetric cores. The memory arrays legal definition. It stores the synapse weights, membrane potentials, thresholds, outputs, for example, number of times that a neuron has spiked, bias amounts and other values used during operation on neural network 200. Volatile, non-volatile memory is used to implement memory arrays. Legal definition of membrane potential of neuron. Each computational logic block is operable to perform calculations for a neuron, determining whether the membrane potential exceeds the threshold and or other operations within a neuron. A neuron refers to logic circuitry, storage of parameters associated used to implement a neuron of a neural network NN. The neuron performs a function utilizing input values to update a neuron membrane potential. Second, it propagates a spike signal to connected neurons when the threshold associated with a neuron is surpassed. Legal definition of a router. Port sets router 104 in Figure 1 is logically divided according to the direction, and the port sets to interface with network elements located north, south, east, west, and other directional links made of one metal layer, core links on a third metal layer of adjoining network elements and or directions of traffic exchanges. Router 104 includes cross-path switching arbitration logic to provide paths of inter-port communication. Figure 1. It's configured for X first, Y second routing, whereby the data moves first in the east-west direction and then in the north-south direction. For example, router 104 includes north port and input and output ports configured to receive and send communications to a network element 102 located in north direction with respect to router 104. Here is the copied ancient replica, which is also the binary code. The binary code is a space map address commonly known as the trigram. It is an ancient replica. It's been around, ancient refers to billions of years. And so then in the north trigram, typical example could be like Russia. In the east would be Dragon 123, CN, Japan, Korea. In the south would be where I am, in the Phoenix. As you can see, this is symbolic of the outer space address. And in the west will be Tiger. And these are the trigrams that represent Tiger in the Americas. This is the copied ancient replica where the perp uses and pastes on his company brand. So you can see here that there's north, south, east, west ports with this core array in the center. And so it is linked to outer space and it's a binary space code. And you can also read this in these glib scriptures. In a story format, which is written by God. And here is a glib name with having of stylized characteristic, which is which is omitted A and before and after, omitted Y before the A and omitted H after the A, and correct pronunciation is Ya, and it shows that it is heaven and earth is parallel and God's Son is the mediator, meaning you have to encode yourself with the scriptures. the outer space code names in every chapter. And here is a copied ancient replica of the Jinx organ space map address for plausible teleportation intent by the perp, which is already pre-built inside log programs. So what I was trying to do was to show that how the perp thought of locking in log steps, for example, some of these WPWT documents. And so this legend is that there is a yellow emperor, and the yellow emperor is in the middle here. And so I used an example of architectural blueprint, which is the Pentagon, and you can see that it is also 5 petals. And what I did was from this tile book that I decoded and located the outer space star address with a present day flag or location, matching the trigrams and also the animalistic symbolism with the current day copied ancient replica on the chip brand, and using the Pentagon architecture as an example, and I paste these outer space planetary which is also connected to the organs, and which is why the biomedicine law and pharmaceutical law, the COVAX chip connected to outer space binary for radio frequency Q. And also, I added some useful illustrations to show that how this ancient trigram over here, which is the binary code, works is that in order to understand, so like this is like an example of a chip pyramid chip on the top, which I will also be elaborating in the head plot. The illegal paste SG, no such architectural of the no such parliament here. They just paste SG and rob blind land on large scale basis and stole the identity and paste SG on themselves. That when the sun is moving, it revolves around the obelisk, thus creating the yin yang, which is also the design for the Korean ATM by PSLT dollar ATM manual. And so with this sundial, they were able, over the obelisk, over 365, they were able to map out the shadows and create a trigram binary formation. And also this you can read in the scriptures of the space code. None of them are surname Wang or King as the first name. It is only at most a title, and all the names in the glyph text are outer space code names. I happen to have a Heaven and Earth God chip printed on me since the day I was born. And so you have these, I paste these planetary code decoded over the fingers of, let's say, a Tao book, and you can see that they try to make formations with the hands, such as in the scriptures you also read in the code name Dawei or David, that also here in the Vedic South, you can see there's a Nehemiah, which is the Nehemiah books. So, and these are all the Ya groups, the omitted Y up before the A and omitted H after the A. This refers to the Asia, and Ruby is not part of Asia. And this denotes the heaven and earth stylized name of God. So you can see that in one scripture it states that David, which is a glyph name or outer space code name, he's not necessarily fully human. He was talking to God and saying that teach his hands to war and fingers to fight. So this could be the context of what he was referring to. And by using his hand, and also interestingly, he is, as the descendants also, he's also in the yellow card. So it's like a combination of both the glyph text and the Tao book. And they are all the saints, which is the correct Thompson, which is, I believe, the Han group. So I paste this planetary to show you that by twitching his fingers and all that, he was able, and also you can read some of these in the WRC where they were doing some kind of flooding in other regions. So the binary code into the space, and this is the Yellow Emperor, which is also a bit like I believe I found out is in dragon terms is the Yellow Emperor is Tiandi. So here, let's look at the spiking neuromorphic computers, which is SNN. It is constructed by tiling the modular neuron codes and synapse cores on an interconnected network, where the synapse cores store and process synapse weights. So it is over here, the chip in body exposed to radio frequency and connected to radio frequency outer space binary codes. In an interconnected network where the synapse cores store and process synapse weights, and 2, the neuron cores store neuron membrane potentials, and 3, it generates spikes. For example, it performs weight integration. To mimic this high fan-out behavior in a spiking neural network, or SNN for short, hardware include a large synaptic array. For example, static random access memory, or SRAM, SRAM, for storing synapse weights. For example, the supporting sparsity or density connecting spiking networks, for example, feed-forward and recurrent neural networks, or restricted or non-restricted Boltzmann machine type network. The SNN network support neuron to synapse ratio by 1 to 1024. The synapse heavy network spiking liquid state machine, or LSM. A synapse heavy network constructed with a 28 by 28 784 neurons on one visible layer, 2 512 neurons in a hidden reservoir layer spiking liquid state machine, LSM. Network process and classify 28 by 28 pixels of modified National Institute of Standards and Technology, or MINIS for short, digits where each pixel is mapped to a neuron. For example, with sparsity of 25% of connectivity, the network utilizes 0.25 multiplied by 784 multiplied by 512 plus 512 times 512 equates to 165, 888 synapses, resulting in a neuron to synapse ratio of 1 to 212 for this network. So the neural network looks like this. There's an input, a hidden, and an output. And figure 2 is commonly termed as the greedy algorithm, and I will be also explaining further in the synapse 1, or using the Korean IBM neural network NN, with a feed forward, and second, a recurrent, and third, convolutional neural network, etc., with suitable connectivity between the neurons. So the links between the neurons are excitatory or inhibitory effect on the activation state of connected neurons. 2 neurons have a synapse weight WXY, where X indicates presynapse neuron, Y indicates postsynapse neuron, indicating the strength of relationship between 2 neurons. For example, when a spike propagates from X1 to X5. So here is X1 all the way to X5. When they propagate from X1 to X5, it increases or decreases the membrane potential of X5 depending on the value of W15. So this is W15. When X1 spikes, the spikes are propagated to one or more connected neurons residing on the same neural synapse core block, or packetized and transferred through one or more routers, 104 to neural synapse core block that includes one or more spiking neuron fan-out neurons X5, X6, X7. When X5 spikes, the spikes are propagated to X8 and 9. So when it spikes, it is propagated to X8 and 9. A nonlinear function, for example, sigmoid transfer function applied to inputs and current membrane potential. Then the neuron updates its membrane potential based on the function output. For example, when the neuron membrane potential exceeds a threshold, the neuron sends spikes to each of its fan-out neurons, means the neurons are connected to the output of the spiking neuron. So to sum up, the Intel pattern of neural synapse cores for spiking neural network and system comprises of memory, the legal definition, and the legal definition of processor defined here with a diagrammatic blueprint. See figure 3a that shows a neuromorphic processor of reconfigurable neural synapse core blocks Figure 3b shows a second neuromorphic processor, including a system of reconfigurable neural synapse core blocks, where the legal definition of processor is set one or more configuration parameters, a configuration parameter to specify a first or second value, and cause the plurality of the first neural synapse cores to be reconfigured as neuron cores responsive to the first value specified by one or more configuration parameters, and cause the plurality of the first neural synapse cores to be reconfigured as synapse cores responsive to second value specified by one or more configuration parameters, when the configuration of a neural synapse core as a neuron core comprises of enabling neuron processing circuitry of neural synapse core. The neuron processing circuitry is update neuron states to configure neural synapse core as synapse cores that comprises of disabling neuron processing circuitry. Next, we look at the MAC emitting address or self-assembling electronic circuitry of the microchip construction, medical observation, and date corps that were COVAX in, for example, Mexico and several other states that were highlighted with medical evidence. That the MAC address generator producing random numbers using the Intel pattern compute near memory convolution accelerator, the legal expedition or medical observation of self-assembling electronic circuitry microchip construction. So over here, you can see that this is the diagrammatical blueprint, that there is a channel-wise input row vector stream. And also there is a number of channels and H is the maximum number of rows in. So this is the chip makeup in the input row vector stream for the current batch. And so this is what the diagram can look like for the MAC emitting generator. There's some computation logic inside. There's near memory to contiguously store channel-wise distributed filter rows. There's an input row vector. And after computation, you create the MAC address, accumulated p-sum, and then output feature map. So in this Intel core pattern, compute near memory convolution accelerator explains a compute near memory CNN convolution accelerator that enables a convolutional neural network or CNN. It claims application to self-driving cars, criminal CCTV installation surveillance, trained with labeled data to produce a model expressed as a set of weights. The model weight combination is used to infer an outcome. For example, I will also be explaining this in the IBM Senjo's paper, the image classification, object detection, and semantic segmentation, and the possibilities as weapons function. Also, a common CNN can include Microsoft Residual Connections Network Model, RASNet, and Google Inception Net Model, GoogleNet. Here's another diagram. The compute near memory convolution accelerator with a clock sequencer unit. There's a near memory weight filters, input buffer, output buffer, configurable registers, with feature map, processing element, control circuit. Figure 1 is a schematic block of integrated circuit that includes near memory and processing. The correct legal definition, COVAX chip, for example, arrays referred as compute near memory CNM. Convolution accelerator 100 is implemented on field programmable gate array FPGA. This is another example by the Intel convolution operation mutual copied by, for example, other brands like IBM. In-place convolution or accelerator where there is an input activation, filter weights, convolve and accumulate over C hash number of channels and output feature map that you can see. After accumulation, there's an output map. So this is an in-place convolution operation repeated over n batches of 3D input activation matrices that can also explain the criminal illegal installation of CCTV for training. So figure 2 is a schematic plot of a in-place convolution operation implemented in CNN convolution accelerator mathematically represented as a 3D matrix operation. H represents input activation, which you can see over here, H, and of height 3D input activation matrix 202. So, and W represents input activation width, and C represents input activation channels. For example, each channel represents pixel colors. One channel can be red, one channel can be green, another channel can be blue. So for the 3D filter matrix 204, S represents the filter height, which is, you can see over here. And R represents the width, and C represents the filter channels corresponding to input activation channels. The entire set of filters for all channels C times S times R is referred to as a kernel K. So now it becomes very clear what is the meaning of K, kernel K. A convolution operation can have more than one kernel K, and each results in a separate output feature F-map 208, total number of output channels. So here is the F-map. In Figure 2, the 2D convolution operations 206 for a single kernel is performed row by row in a 1D fashion to obtain partial results known as partial sums or p-sums used to form rows of F-map 208. The weight matrix. It possesses a convolution layer based on operations using 1 by 1, 3 by 3 weight matrices referred to as filter or kernel on larger matrix of multiple input channels of image or video data known as input activation. The 2D convolution operation is reformulated as a 1D row-wise convolution, which enables CNN convolution accelerator to process input activations row by row using weights 1 by 1. It is mentioned the legal word vector stream as weights and input rows to MAC units enables CNN convolution accelerator to implement convolution for both 1 by 1 and chosen n by 1 size filters. At least one array of multiply and accumulate, which is the short term MAC also, and also copied by the other patterns like the IBM units is coupled to the circuitry and at least one array of MAC units to compute near memory CNN circuit block of a CNN accelerator from selected weight and input activations and partial sums for convolution wherein the circuitry enables access to the memory and input buffer by at least one array of MAC units to accelerate the convolution. The integrated circuit comprised of systolic array of CNN circuit blocks arranged to accumulate partial sums computed by arrays of MAC units in a systolic array of CNN circuit blocks into output feature map. So this is the Intel Corp Figure 3AB row-wise convolution operation. There's an input activation row, the weights, and the p-sum. Figure 3A to B is a schematic block diagram of a row-wise convolution operations. In Figure 2 and 3A, the 2D filter matrix 204 for one channel C is separated into three 1D filter rows of size. 1 by 3, 304 to 1. For example, the field size is S times R or 3 by 3. And it is strided over a single row of input activation matrix 202. At each stride, the 1D convolution is performed to compute a partially constructed output row referred to a partial sum or p-sum 306. Thus, the 3 1 by 3 filter rows of 3041 is convolved over an entire input activation row of 302 to compute a partially constructed output row or p-sum 306. The 3 1 by 3 filter row 3041 separately convolved the input activation row 302 results are added element-wise to your p-sum 306. The same set of operations repeated over all input activation rows, for example, 1 to H on input activation 202 over all channels C for 3 filter rows 304 to form resulting p-sums 306 to form output F-map 208 in Figure 2. Cycles refer to convolve operations 301 include stride operation by 1 to stride all three weights in a 1D filter 304 with dimension 1 by 3 over single input activation row 302 to obtain p-sums 306. Y0 to Y5 in 6 cycles, 308, cycle 0 to cycle 5. So you can see some example diagrammatical illustration of the cycles, how they got the value of from p-sum of Y0 to Y5. Figure 3B, an alternative 1D operation 302 includes same stride operation, stride by 1 to stride single weight ABC 3042 of a 1D filter 3041 with dimension 1 times 3 covers single input activation row 3 to obtain the p-sum. So this is referring to the cycles here. Here is an example of what I obtained to show that there is such a thing called neural grid. And for example, this is like a circuit board. The university of any names can just it is manufactured elsewhere, so it can be like a standard circuit board, and usually like suppose the university is teaching a course, they can paste the university name, but it's actually, for example, could be made in any of the other continents, for example. So figure 1 shows a board of neural layer stimulated by 256 silicon neurons on each of the 16 neural cores integrated on board. So I just wanted to show that what it looks like. And you can see the word neural grid over here. I end this section. Thank you.